Hello, this is a video for EDX Statistics 1. It is the first video in the series on discrete random variables, mean and expectation, and it will cover the properties of a probability distribution. First of all, some terminology. A random variable is considered to be a variable which can take a set of values, each with an associated probability, and its value changes due to chance. Often these values will represent the outcomes of an experiment you're going to do or one that you've already carried out. An example of this would be throwing a standard six-sided dice and using the random variable x to represent the score obtained on the dice. Clearly in this case the possible values for x would be the integer values between 1 and 6, and the associated probability for each of these outcomes is 1/6. This would be considered to be a discrete random variable because only these 6 outcomes are possible. Values in between such as 1.9 or 2.1 aren't. We generally use a capital letter to represent the random variable itself, in this case the score on the dice, and then the same lowercase letter for the values it can take. So the score on the dice, capital X, can take the lowercase x values 1, 2, 3, 4, 5 and 6. When we talk about a probability distribution, we mean a model giving all the possible outcomes with their associated probabilities. So here is the probability distribution for the previous example about the six-sided dice. As you can see, we have all the possible outcomes on the dice with their associated probabilities. In this case, where all the probabilities are the same, this is referred to as the discrete uniform distribution. Another way of writing a probability distribution is by using a formula. So here we have the formula for the probability of the score on the dice being any particular number x is equal to 1/6, where the possible values for x are the integers 1 to 6. To be a valid probability distribution, there are certain properties that must be satisfied. To begin with, all the probabilities must actually be probabilities. They must be greater than or equal to 0. And secondly, because you're listing all the possible outcomes, they must total, the sum of all those probabilities must be 1. There's a couple of algebraic ways of writing those conditions. So in this top one, we have the probability of any score from your random variable being a particular value is greater than or equal to 0 for all possible values for x, and that upside down a means for all, and the x we're talking about is all the ones in our scenario. So that's the first property. The second property here is this capital sigma, which means the sum of the probabilities must equal 1 when you consider all the probabilities together. So again, that's for all possible outcomes of the random variable. A standard question in this topic is to give you a random variable with an unknown and ask you to find it. So a question like this. So here we have a random variable x and a formula for how to find those probabilities. And we have just these 4 possible outcomes. Now we need the fact that all the probabilities for this distribution will add up to 1. So if I can find an expression for each of those, then I will be able to find the value of k. So to begin with, I'm just going to list the probabilities for different values of x. So in each case, I'm going to substitute in a value of x. So for the first one, this will give me 2k, because I've got 2 to the power of 1 times k. In the second one, I'm going to get 4k, because that is 2 squared times k. In the third one, I'll get 2 cubed times k, which is 8k. And in the final one, I'll get 2 to the power 4 times k, which is 16k. Now we know that because these are all the possible values for this random variable, that they will add together to give us 1. So if you add all of those up, you will get 30k, and we know that that adds to give us 1. So solving this equation, this gives us that k is equal to 1 in 30. Here is those calculations typed up. That's the end of this video. The second video in this series is about the mean and variance of discrete probability distributions.